I'm Nicole Woodaslawski from the International Copper Association. My colleague, Malcolm Burwell, continues his interview with Jack Lifton, founder of Technology Metals Research.
Now, you remind me, Jack, Jack, you remind me that when the samarium cobalt crisis happened, the car industry, led by GM, recognized the threat to their existence and worked with a large Japanese company to develop an alternative magnet technology. Do we see the large OEMs recognizing the threat to their existence and doing something big to grab hold of the problem yet?
Yes. However, the first that I noticed to start working on it was Toyota, then Daimler, then I'm talking the large ones, then GM, then Ford. But I'm telling you that companies like GM are behind the others, but they are working on it, no question. We do not have a worldwide attack on this. The Germans seem to be doing it all together, and we understand competitive situations. But no, there's no uniform approach to this. It's individual. Some companies are doing better than others, but to the best of my knowledge, the only company that has so far built a supply chain, a total supply chain, is Toyota, and including the fact that Toyota is well underway now to developing its own mining facilities in Southeast Asia.
But your previous comments about the intractability of the supply and demand would imply that that's only a short-term solution unless they change the technology away from at least dysprosium. Is that right?
Yes. And the problem is this. You know, you're talking about technology that you know took 30 years to develop. And when I hear people say, well, they will substitute, they will thrift, they will do this, they are not finding this so easy to do. And the point is, these products were developed specifically to solve problems that they did solve. Now you're saying, do something else. Does anybody remember that during the development of these things, we looked at everything else, and it didn't work? And for some reason, the public thinks there are new elements coming along on the periodic table or new science. My favorite nonsense is nanotechnology, because no manufacturing engineer on this planet knows how to make a large quantity of such fine material, transport it to a factory, put it into products, keep it in the state it needs to be to do its function. These are all laboratory curiosities, and yet there's so much press about it. I'm a member of American Chemical Society and all that. I get 30 and 40 papers a day on nano this, nano that. It's just wonderful for applying for grants for university professors. But when I ask people, for example, I know a gentleman who's manufacturing lithium-ion battery electrolytes, and he's supposed to be involved with nano this and nano that. He said, Jack, I can only make a few milligrams of this stuff. He said, it's just a curiosity. We can't do that in production. We don't know how. Now, and then people are saying, well, let's stop using this. Instead, we'll use bananas. Well, how are we going to make nano bananas? Nobody thinks about manufacturing engineering, which is the absolute, link in the chain that's broken. You can have all this university stuff, all this wonderful academic stuff, but at the end of the day, if I can't make it in mass production at a price that Joe Sixpack can afford, what do I need it for? Everybody thinks the model is the Karma, the Fisker Karma, or the Tesla. These are toys for rich people. Electric cars for everybody require cheap technology. That's the problem.
Jack, I'd like to thank you for your time with us today. Our listeners should know that excerpts from your blog are featured on the International Copper Association's new Copper Rotor Induction Motor web portal site, www.coppermotor.com. Good luck with your presentation at the SAE Symposium on Monday. I look forward to seeing you there.
Thank you. Thank you very much.